All right, greetings, wonderful people. Let's see what we're working on today. So today we're going to apply the order of operations when evaluating numerical expressions and simplifying the answer as much as possible when evaluating numerical expressions. So those are our two objectives, the two goals that I'd like to cover today. So really quickly, how many steps are in the order of operations? Now this one's kind of a, there's a lot of misconceptions about this one, because if I ask most students, how many steps are in the order of operations? They're usually going to say 6. But what are those operations? So we have groupings. That's the first one most people will remember. Now this one's misremembered as parentheses. But the first step is not necessarily parentheses because there are way more ways that we can group something other than parentheses. So brackets, braces, absolute value signs, and fraction bars. Those are all considered to be grouping symbols. After that, it's exponents. And then multiply and divide from left to right. Now there's also some misconceptions about this one as well, and I'm going to get to those in just a second. And add and subtract from left to right. So actually there are 4 steps in the order of operations that we usually do. Now the other one that I was mentioning, PEMDAS, it kind of works, okay? It'll get you the answer you're looking for most of the time, maybe 9 out of 10 times even. But in reality, sometimes it's just a little bit more complicated than that. So order of operations, and this is what you can see on your packet. So you have grouping symbols, and again, it says it includes fraction bars, exponents and roots. So that's another distinction, because when we think of exponents, we generally don't think of roots. But actually, roots and exponents are the same thing, they're just backwards. Okay, so let's go ahead and I'm going to show you a quick problem, and I want you to do this problem in your head as fast as you can. Now, it doesn't matter whether you get it right or wrong, because if I had a large class, and I've been using this example for many years, and I will get half the students usually, it's somewhat of a medium divide. So look at this and think, what do you get? What is the answer to this? So I usually get 2 different responses, and I'll usually tell students something like, answer it as quick as you can. And I'll get some students that'll look at this, oh, it's 2. And I'll get another group that will look at it and say, oh, it's 8. Now math has to be predictable. It has to follow a set of rules, right? You have to be able to get the same thing every single time you do it. Otherwise, what's the point? So is it 8 or 2? So I'm going to do this the wrong way first. So there's that, again, this works and it's everywhere. It's on posters. I've seen it in schools, posters at the teacher shop and online. Everywhere you go, you're going to see this. But there are some misconceptions about it. And this is one of the first misconceptions, and that is there is not 6 steps. There are 4 steps, because multiplication and division are the same step. And again, this helps you remember it, but a lot of students will go, this is their thought process. They go parentheses, exponents, multiplication. So they see the multiplication and they will do that first. So they will get something like 40 divided by 20, and that's how they got 2. But again, that's not the right answer, because if you read it carefully, it says multiply and divide at the same time, but moving from left to right. So if I move left to right, you notice that we hit a division first. So you could also say PEDMAS and it would still be correct. So we got to take care of this division first. So that would be 40 divided by 10, which would be 4 times 2. And that's how we get 8. And again, 8 is the real answer. And I have another one, same thing. Go ahead and get the answer as quick as you can. Think about it. Now in this case, I don't get a lot of students that get this one wrong, but that's not really the trick with this one. The trick is explaining it. So I'll usually get students that will say, ooh, it's 12. And yes, it is 12, but I'm going to ask them, how did you get 12? And they'll say, oh, you add the top numbers and then you divide it by the bottom number. And I'm going to ask them because, again, so a lot of times they don't know about or they're still using PEMDAS. So I ask them, why did you add before you divided? Right? Because add is way back here and divide is in front of it. So why did you add before you divided? And a lot of times they'll be stumped and say, you know what, I don't really know. I just sort of thought of it. I just sort of guessed at it and it turned out to be right. And again, it is right, but the why is it like that? And that's because these are grouped. The top numbers are grouped because fraction bars are grouping symbols. Right? So fraction bars are grouping symbols. So if you see something on top of a fraction or on the bottom of a fraction, those are all considered to be a group. All right, so let's go ahead and move on to some of these exercises. Simplify each expression. Okay, so we just have to follow our order of operations here. So to follow the order of operations here, let's see. We should take care of, okay, so here I have a group, right? We have 11 and we have a exponent of 2. But in this case here, if you have a group and you have things inside that group, so you start over again. So if I look at this group here, I have a subtraction and an exponent. So subtraction and exponents, those are the two things going on in this group. So I got to fix this group before I move on to anything else. So let's take care of the exponent because that would normally go before just about anything else. So exponent, so let's see, that is 2 to the 3rd power, which is 6, right? No. Don't forget, an exponent means, it doesn't mean multiply. It means multiply by itself that many times. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So the actual next step in this would be 8. All right, and now I'm going to go ahead. Now I don't have a division symbol here, so I'm going to just use the slash symbol. Although if you're writing this, you should probably write that division symbol. I think it'd make a little bit more sense. All right, but for this one here, I'm going to just go one step at a time just so people don't get lost. Now, I'm going to go ahead and do this grouping symbol here. So I now have 11 minus 8. Now, sometimes you might need your parentheses. Sometimes you don't need them. So if I write it like this, do I need these parentheses here on the 3? No, don't need them. Okay. So since we don't need them anymore, they're not holding any groups together, right? Because you shouldn't really have a parenthesis if there's no group. Sometimes if you have a parenthesis, it can also mean multiplication. So a lot of students will mess that up as well. They'll look at like a big problem like this, and then they'll see parentheses, which are multiplication, and they'll think, ooh, I should do that first. So again, I don't like the PEMDAS because parentheses don't always mean grouping symbols. So you kind of have to make a judgment call on that one. But in this case, we don't need the grouping symbol anymore. Now let's see, we still have a division. So we got to take care of that division before we work on anything else. So I'm going to leave everything else the same and go with 36 divided by 4. Oopsie. Which I think is 9. Let's see, 40 divided by 4 is 10. 40 minus 4 is 36, so that'd be 9. Yeah, it would be 9. So be careful with that one. Now we have only addition and subtraction, so now we just got to move left to right. And you don't really have to do this one left to right, but it's a little bit easier to work on going left to right because you don't have to worry about changing signs or passing. I call it passing the 0. basically a number goes from positive to negative, and sometimes it can go back and forth between positive and negative several times, and that can get confusing. So let's just stick with the order of operations we were given. So 29 minus 3 is 26 plus 9, and that's going to be 35. So there we go. We finally reached our final answer. Now, when it says to simplify, in the directions where it says simplify, that means to get it as simple as you can possibly make it. So in this case, this is the simplest it can be because it's only one number. The simplest, the most simple. I guess simplest, yeah, because otherwise most directions would say simplest form. I don't know, I'm not an English teacher. Anyway, let's go ahead and do this one here. So here I have 4 to the 3rd power, so that means 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4 is 64. All right, now here I have an absolute value sign. The operation is the absolute value. So with the absolute value sign, I'll oftentimes ask students, do you know what it means? And can you explain it to me? And I'll usually get something along the lines of, yeah, whatever you put in there becomes positive. And it's not wrong. That's kind of right. That is kind of what it is. But it's not the entire story. But to keep it simple, the absolute value of a number is the number's distance from 0. So in this case here, we have -8. So if you imagine a number line, right, -8 would be somewhere over here. So like if this finger was -8, you know, and I move it over, it would still be +8. I'd have to take 8 steps to go back to 0. But another easy way to remember this is that you cannot have a negative distance. If you get in your car and you drive to the store around the corner, did you go backwards, -200 feet? No, because you can't go negative distance. If you drive backwards, you're still going a positive distance. You're not getting more gas in your car by driving backwards. So distance is always going to have to be positive. So now I used it. So now it is a parenthesis. Now you don't really have to do this every single time like this, but I'm just showing you where that negative went, and it's gone because we use the absolute value. We don't need the absolute value sign anymore. So I'm going to put it in a group by itself. Now in this case, we don't really need that group by itself. So we just say -8. And I'm just going to put everything back here. So there we go. So I just got rid of that parenthesis. Now here, if we were following PEMDAS and we look at this and say, oh, multiplication, then division, well, we would have still gotten it right. And like I said, it works a lot of the time, but it doesn't work every time. So that's why you have to kind of know a little bit more about order of operations than just PEMDAS. So this is going to be 8 times 6, which is 48. And 48 divided by 16. So 48 divided by 16, and I'm pretty sure I know what that is. I should no. 16, 32, 40. Okay, yeah, it is going to be 3. Excuse me. And then 64 minus 3 is 61. So there we go. We've gotten this thing entirely simplified. So we only have one number. Can't get any more simple than that. Okay. Now these exercises are they're lengthy. So just got to be careful. Now, sometimes I type these out, but in this case here, since I'm dealing with fractions, I don't really want to type these out. And forgive me, but I'm going to have to do a little bit of extra work. Okay, so I'm not going to be sticking with one thing at a time each step, because if I did one thing at a time, I would quickly run out of space because I only have this much space to write the work in. So with only a limited number of work space, I really don't want to run out of space, because if I run out of space, then I can't really do much else. And I can't really, if I write it somewhere else, then it's going to get confusing. So I'm going to just try to keep everything here. All right, so 7 minus, and let's go ahead and use this now, 10 minus 12. So I have a grouping symbol inside of another grouping symbol. So work from the inside. 10 minus 12, now 12 is bigger than 10, and since we're minusing it, it's going to make it into -2. Now, again, I did say that I was going to have to kind of go through and do more steps at once. So I can do these steps too. So 5 squared. Now, let me see. The rule is you can do two things at the same time if they are separated by a lower operation. So in this case, basically adding and subtracting are the lowest operations you can get. So in this case here, I have an addition. I can go ahead and do this separately, well, at the same time, and it would still be separate. It's not going to affect the answer over here. All right, now 9 minus 2 squared, so that would be 4, like that. And there we go. Okay, so like I said, see, this is a lot of writing here. So let's go ahead and move over here. 7 minus, and let's see. I'm going to use that absolute value. So instead of 2, it's going to, well, -2. All right, I also have to keep this parenthesis here just because. So that's going to be +2 plus 25. And I can probably also do this as well, because again, these bottom two numbers are grouped. So 9 minus 4 is going to be 5. And let's see, 7 minus, and then 2 and 25, put those together, you get 27. 7 minus 27. Now we have a larger number subtracting, so that means we're going to end up with a negative number. So -20 over 5. So I end up with a negative. Now, if you remember your operations with integers, if you have a negative number divided by a positive number, you're going to end up with a negative result. So -20 divided by 4, I'm sorry, divided by 5 is -4. So -4 is going to be the answer for this one. Okay. Whew. So again, some of these have a lot of writing in them, but not so bad. You know, you just got to keep following your order of operations and do what you can. Now, again, even though I had to kind of combine some steps, you know, I filled up this whole side of the workspace. Anyway, let's go ahead and continue on. So here I have 2 minus 3 squared. So 2 minus, and I'm going to go ahead and square 3, so that would be 3 times 3. So 3 squared is going to be 9. Now there's also another square here. Now, because there's a plus sign, I can go ahead and work on whatever's over here, and it shouldn't interfere with my answer. So in this case here, I have root 81, which the square root of 81. Now wait, hold on a minute. In PEMDAS, where does the root go? Okay, now if you remember on the packet, it does explain that it says that exponents and roots are the same thing. Now this is also another misconception, and that is multiplication and division are opposites. No, they're not opposites. I'm going to say something that'll probably blow your mind, but multiplication and division are actually the same thing. It's just going backwards. Okay, it's the same car, but one's driving forward, the other's driving backwards. So just because you put a car in reverse doesn't make it a new car. It's the same car, it's just going backwards. Same with addition and subtraction. One goes forward, the other goes backwards. It's the same thing. That's why we don't have separate steps. It's the same step, just backwards and forwards, basically. And with exponents and roots, it's the same thing. If you remember from the previous lesson, when we were working with properties, basically whatever two numbers multiply to get, okay, so what two numbers multiply to get 81? Well, that'd be 9. So the square root of 81 is going to be 9. So again, it's basically like if I said 9 squared, it would be 81. So again, it's the same thing, just backwards. So that's where roots go on the order of operations. So, and this is another one that I get a lot of too. I don't know why students do this, but they always seem to ignore division. Like division just somehow doesn't go in there. So in this case here, I would oftentimes get students that would probably go 10 minus 6, which would be like 4 or something. But no. You got to do the division. So in this case, 6 divided by 3 would be 2. So that'd be minus 2. Okay. 2 minus 9. Now be careful because this is another thing that's important too, and that is grouping. When you're grouping something, like in this case, these two numbers are grouped, 2 minus 9. There's a group there. That would be -7. Now I have to put this in parentheses, especially when you're working with exponents, because this negative is included with the exponent. And I have some examples later in the lesson that kind of show, you know, what happens if it's not put together. But in this case here, this is -7 times -7. So again, the parentheses, inside the parenthesis is the negative also. Because again, 2 minus 9 is -7, so it goes in there. If it's not in there, then it's not included in the exponent. So negative times negative is positive, and 7 times 7 is 49. So 49 plus 9, and that would be 58 over 8. Okay, so in this case here, if we're working with a calculator, 58 divided by 8, you get something that looks like this, 7.25. Now, one thing I notice is that I've been a teacher for like 10 years, and I've worked with college students for about 10 years also. And one thing that bugs me is that I always get college students that don't know how to do fractions. So they always want to put things in decimals, but fractions are really important because a lot of things in real life still use fractions, okay? If you look at a ruler, it's going to be full of fractions. If you look at all sorts of things, you know, you can find them everywhere, and it's kind of sad because we do need to use fractions, you know, like a gallon, quart, cups, and all those things. Those are going to be fractions, you know. So we got to have an understanding of fractions, so don't ignore them. So when I do these things, I usually don't ignore the fraction. All right, so I try to put things in fractions. So if you run into a fraction, there are two things you should try. The first thing you should try is to divide it, which in this case, it does not divide into a whole number. So since we can't divide it, we should reduce it. So reducing it, you'd look at the top number and the bottom number and think, what is the number I can divide both of these numbers by? So in this case, they are both even numbers. So since they are both even, we should be able to divide them both by 2. So 58 divided by 2 is 29, and 8 divided by 2 is 4. Now, if I use a calculator, I'll still get the same thing. I will still get 7.25, which actually that is also another way you could write this too, is 7 1/4. Which if you were measuring something like by feet or inches or something like that, yeah, you would put 7 1/4 inches or whatever. All right, so let's go ahead and move on. So on the bottom, either of those two would be good. All right, if you know how to do mixed numbers, great, you know, go ahead and do mixed numbers. I kind of feel like I should take a couple of days out of the lessons one of these days and go over fractions again, because I think it is one of those things that we do need to make sure everybody knows. All right, so this is one big bracket, so that's a big parenthesis kind of thing. Now, when I write it, I do want to, I usually try to keep parentheses together. So it depends, it's up to you. You can go ahead and keep your parentheses if you want. So let's go ahead and work on this one here. So 15 So I'm going to turn this into a parenthesis just so it's easy to draw. And here I have an absolute value again, so -4, because 2 minus 6 is going to be -4, plus, and then I have √9. So what two numbers can I use to multiply to get 9? All right, that'd be 3. And like again, I did, if you have a plus or a minus separating them, then it should be pretty easy to do. You can do them at the same time and they won't interfere with each other. 3, and then I'm going to take this 3 and square it, so that'd be 3 minus 9. There we go. Now, let's see, we got to do all of the top and all of the bottom, and then see what we get at the end. So 15, and don't forget the parenthesis here, or the grouping symbol, I should say, minus, and then -4. So take the absolute value of -4. And again, it just pretty much turns anything positive. So that'd be +4 plus 3 all over -6. Oh, wait a minute. Oh, okay, hold on. That 3 to the 3rd power is not going to be 9. It's actually going to be 27, because remember, this is not a multiplication. That is really 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So that would actually be 3 minus 27, which, since I'm subtracting a much larger number, that would be -24. So be careful with that. That is something I see that goes wrong a lot. But anyway, darn. I really don't want to write this whole thing over again to do one thing, especially when it's something simple, but I don't want to lose anybody. So I'm going to go ahead and add 4 and 3 together, and this would be 7. Okay. And now I have to do 15 minus 7, which is, I think, 8. So 8 squared. Now, I don't really need the group anymore, because you can't really have a group of one person. Like, if you're one person, you can't be a group. So if you only have one number, it's not going to be a group if you only have one number. So I don't need the parentheses anymore, because I already know what 5 minus 7 is. It's going to be 8. And here I get 64 over -24. And again, I have a fraction, so we should try to divide it, which it does not divide nicely. And since we're working with fractions, we should divide our fraction as much as we can. So divide, think of a number that can divide 64 and 24. Now you could divide both of them by 2 because they're both even numbers, and you'd get something like 32 over 12. But that would also mean that you would have to do it again. So a lot of times what we do is we look for the greatest common number that we can divide both of them by. So we could divide both of them by 4. That would also work. And if we did that, we'd have to check it again to make sure there's no other numbers we can divide them by. But you got to have it in the simplest form. In this case, 8 is the largest number that I can divide by 64, and 24 can also be divided by 8. So I'm going to divide both top and bottom numbers by 8. So 8 and -3. And again, we end up with another fraction. So there we go. And if you try to take 8 divided by 3, you will end up with a repeating decimal. So in this case, 2.66666. Repeat. And in most professional environments, they don't want repeating numbers. I mean, repeating numbers just don't look very professional, and rounded numbers don't look very professional either. So just in my experience, I think a lot of places would prefer you to use fractions rather than repeating decimals. And since most decimals will end up being repeating decimals, you just got to be prepared with whatever. So again, fractions are just better. Fractions kind of tell most people a little bit more than decimals would. But again, it all just depends. Like if you're a chemist, I'm sure you probably be dealing with decimals way more than fractions. Anyway, going to the next one here, number 6. So I have two groups, right? I have a group here times a group here divided by this group down here, and then minus the absolute value of -5 after all that. So let's go ahead and put this together. So 9 minus 15. So 9 minus 15 is going to be -6. Yeah, -6. Now again, when I put the parenthesis in here, right, this parenthesis needs to include the negative in there. Because when you have an exponent, you gotta know whether you're multiplying it times the negative or the positive of that number. So in this case, the negative is in there, so we know that it is included. Whereas, okay, this one here looks like we're gonna have to go 2 square, which is gonna be 4. Eeh, gonna be tough drawing a straight line. Close enough. Root 49, so square root of 49. So what two numbers multiply to get 49? Yep, that's right, 7. Now in this case here, I'm gonna take the square root, the absolute value. So absolute value of -5 is gonna be +5. So that's where I get this 5 from, but I don't need those parentheses. But one of those negatives is still there. So we got rid of one of them, but not both of them. So that's gonna stay a negative number. Okay, keep going. So I have -6 squared. So that's gonna be -6 times -6. So a negative times a negative is gonna be a positive, and 6 times 6 is 36. And then 7 minus 4 is going to be 3. And then 7 plus 5 is 12. And here, I'm gonna go ahead and go 36 times 3, and that's gonna be 108. So 108 over 12 minus 5. So 108 divided by 12 is gonna be 9. And this means that we're gonna get 9 minus 5, right? The 5 is gonna stay here. We just divided 108 by 12. And 9 minus 5 is going to be 4. So the final answer on this one is 4. And again, that's the simplest form that we can put our answer in. So let's go ahead and box that up. And that is going to be it for that. Okay, so there we go. Now, we use this word expression. So what does an expression mean? What does it mean? So if I asked you an equation, what's the difference between an equation and an expression? An expression does not have an equal sign, and an equation does have an equal sign. So that's why it doesn't say solve it, it says evaluate it. So in this case here, the direction says to evaluate the given expression with the variable replacements. So this is another misconception that happens a lot in math classes, and that is, when I ask students, what should we do with this? Like, a problem like this, I say, what should we do? And they say, solve it. But we're not solving anything. Solving is when you try to get a variable by itself. But in this case, we are evaluating. So I kind of wanted to make sure that that people understood this, that evaluate means everything. So if you see the word evaluate, it means do everything. So if you go to the hospital and you're not sure what's wrong, and you tell the doctor everything you can, and the doctor doesn't know what's wrong either, a lot of times they might do an evaluation. And an evaluation means they test you for everything, right? They might do blood work, they might do x-rays, they might do those tests that end in gram, like sonogram and stuff like that. They're gonna have to do a lot of things, because if they don't know what's wrong with you, they're just gonna have to test you for everything. So that's what they call an evaluation. Or like if you're taking a test, right? They check you for everything. Like teachers get evaluated. That means we're checked on everything we do. So anyway, let's go ahead and get to this here. So what we got to do is replace each of these letters with these numbers. So if we see an A, that means we replace it with 3. Now here's where it's important, because I'm going to replace b with parenthesis and drop in -4. And like I said, be careful when you're dealing with exponents and groups, because sometimes you might have something outside of that group. Like in this case here, I think there's also some other examples where something like that's going to happen. All right, now continuing substituting, which is what we're doing. This is called substitution when we replace it. So C has been replaced with 8. We're substituted with 8. And substitute just means, again, replace, like substitute players in for a game, or to substitute teachers. You know, just basically to put it in there, fill in the space. All right, now we can go ahead and start evaluating. So let's go ahead and work with our top number. So 3 times -4 squared. So I'm going to go ahead and square -4. So -4 times -4 is 16, which is going to be positive 16 because, again, -4 times -4. And then 8 plus 12 is going to be 20. And 3 times 16 is going to be 48, which in this case here, nothing's going to happen with my bottom number, but we cannot divide this because it won't divide nicely. If it was 40 divided by 20, we could easily divide it, or even 60 divided by 20, we could easily divide it. But again, we're going to have to end up reducing it. Now, in the last time we reduced these fractions, I had you think, what is the largest number that both of them can be divided by? But I'm going to show you another way, and this might be easier or not. I don't know. People are different sometimes. But what you could do is just quickly look at these and think, okay, well, what can I divide both of them by? And since they're both even, you might think, well, you can divide both of them by 2, which is true. Both of them will divide nicely by 2. But then you have to check it again, all right? Because before we looked for the biggest number, and if we can easily think of the biggest number, we can go almost straight to the answer. Now, whenever we do this, we have to make sure to keep going, because again, we have to put it in simplest form. That's one of the objectives that we stated at the beginning of this. Make sure you simplify the answer as much as possible, right? So that was the second objective. So in this case here, this is not the simplest. So let's go ahead and try again. So divide both of them by 2 again. So top number divided by 2 and bottom number divided by 2. Now in this case here, there are no more numbers that I can divide by. There's no number I can divide by 5 and then also divide that same number by 12. So it doesn't work. So in other words, this is going to be the simplest form. And again, you could also put this in mixed number, which if you were to put it in mixed number, it would be something like 2 2/5, which again, I want people to understand fractions a little bit better. Sometimes it's good to use decimals, but I think it's important to practice fractions as well, because fractions aren't going to just disappear when you graduate. In fact, they're probably going to be more common than after you graduate. But like I said, it really depends on what you do after graduation. All right, let's go ahead and keep going with this one here. Now, in this case here, I'm not dealing with any fractions, so I'm going to go ahead and just put it into a, I'm going to type it. Typing is a lot easier to read. All right, so I'm going to go ahead and plug them in. So I have m and n. So m is 2 and n is -3. So in this case here, I put a parenthesis where n used to be, and I'm going to drop in a -3 in there. So make sure you put these in the right spot. And like I said, it's a good thing to have parentheses sometimes, especially if you're not really sure where these things are going to need to go. But I'm going to go ahead and multiply 10 and 2, so we get 20. Now in this case, in this next one here, we have two things going on. We have 8 times -3, and then square the -3. So we have a times and an exponent. So I'm going to take care of that exponent first. So -3 squared is going to be 9. So again, -3 times -3. Negative times negative is positive. So remember, your rules are different when you're multiplying or adding or subtracting or anything else like that. All right, so still absolute value. 20, and then 8 times 9 is 72. So we got a minus 72. Now in this case, it'd be negative 8 times 9 would be negative 72. So you would read that as 20 and negative 72. Or 20 minus 72, whichever, you know. It's a lot easier to think about it the way I said it, 20 and negative 72, because that way it's easy for people to be like, okay, well, these are two different things. Whereas if I say minus, then it makes you think that you're always going to do a certain thing. But when working with positives and negatives, sometimes it can be a little tricky like that. All right, so in this case here, we have only one last thing to do, and that is to take the absolute value of negative 58, which is going to be positive 58. And there you go, we are done with that one. Okay. Moving on. Now in this case here, for this next one, we have each of these kind of bring a little bit of a trick to them. All right, but for this one here, the trick is that we are, oh, okay, this one doesn't really have a trick. Just gotta make sure we're putting these numbers in the right place. Sorry, I'm getting a little bit ahead of myself. I was looking at this and I thought it was a different problem. All right, so we gotta replace x with 5 and y with negative 9. So again, everything's gonna introduce something new, and this one looks like it's introducing that we got this inside the group. So in this case here, I don't really need to put a parenthesis on this one here because it's just negative 9 plus 2. So, but with this one here also, we have negative x. So basically this is telling us whatever number we put in here, we have to make it negative. Now, this one is the one I was talking about where I was saying if the negative is on the inside of the parentheses, you multiply it like if this one had the negative on the inside, it would be negative 5 times negative 5, which is positive 25. But this one is going to be the different because if you look at it, the negative is on the outside. So being on the outside, it's not going to be affected when we use the exponent. So this is positive 5 times positive 5, which is 25. But the negative is still there. We didn't get rid of it. So in other words, this one stays negative 25. Okay, now for this one here, moving on, negative 9 and 2 would be negative 7. So I'm going to go ahead and put those two together. Now, again, remember how I said you got to watch out for these and ask yourself, well, does this make a negative or a positive? Because in this case, this is still a group. The parentheses are still being useful right here because they're being used as a multiplication now. It went from being a group to being a multiplication symbol. So sometimes in order of operations, it can switch from one to the other. So you got to be careful, or watch what you're doing. So in this case here, we have stays negative 25, but I have 7 times negative 7, which is negative 49. Oops. Now I have triple negative numbers, negative 25, negative 49, negative 1. Now, do we have to go with the left to right rule? Not necessarily. Instead of doing the first two, I could do the second two. Now, be careful again, with all of these shortcuts, you always want to make sure you know what you're doing before you start working on them using the shortcuts. So in this case here, I'm going to put negative 49 and negative 1 together because I think in that case, it would make it much easier to add. Like if I told you, what is 25 plus 49 plus 1? Most people would sit there. But if I ask you, what is 25 plus 50? Like that was any sort of, like that was hard? No, it'd just be negative 75. Now, also be careful with this one because if you have a negative combined with another negative, or a negative minus a number, then you get a bigger negative. It's not like multiplication where you multiply two negatives, you get a positive. If you combine two negatives with adding or subtracting, you get a bigger negative. So in this case here, we end up with negative 75. All right, now this one here uses fractions, so I might end up having to just write it out. I know typing it is a lot easier to read and sometimes a little faster, but in this case here, since it wants us to use a fraction, it looks like we're gonna have to go with what they want. So 3 times 5, because we replaced r with 5, and 4s, with s being replaced with 2/3. All right, so 3 times 5 is 15 minus, and like I was saying, I think I really need to take a week and review some of these fractions operations, because in this case here now we're multiplying a whole number times a fraction. But we'll see how we have time for that. But to do this one here, basically the easiest way to do this is to make both of them into a fraction. And we're going to use one of the properties we learned from the previous lesson, and that is identity property. So identity property says that you can do something and still get the same number. Like in this case here, 4 divided by 1 is still going to be 4. But in this case, it kind of helps because I can turn it into a fraction now. 4 over 1 is still going to be 4. 4 divided by 1 is still 4. Just like if you had 4 Twinkies and you were going to share it only with yourself, you would get 4 Twinkies, which you shouldn't eat 4 Twinkies on your own. But, you know, just to show as an example. Now, since both of them are fractions, I'm going to multiply top number to top number and bottom number to bottom number. So 1 times 3 is going to be 3, so that means I get 8 over 3. Now, this doesn't really help a lot because we end up with another whole number and another fraction. So we're subtracting 8/3. And just so you remember, this is kind of roughly equal to 2.3. So it would make sense that we'd get a number around 13 maybe. But again, let's just stick with the fractions. So with this, I'm going to do the same thing. I'm going to turn it into a fraction by putting 15 over 1. And multiplying fractions is a little bit easier, but adding and subtracting fractions, addition and subtraction, that's a lot more difficult, because one of the rules with working with fractions is you need to have the bottom number the same, right? You can only combine them when the bottom number is the same. Otherwise, it's not going to work out. So I need to make both of these bottom numbers match. And how can I do that? Well, easiest way to do that is to change both of them to the same number. In this case, I'm going to pick that I change both of them to 3. Now, the second one is already 3 with a bottom number, so I can just leave it the same. But what do I need to do with this one here? Well, I need to times both top and bottom by 3. So we know how to simplify, right? We know how to simplify fractions. Divide the top and bottom by the same number. But when we unsimplify, I don't know how you would say that, complicify. But what we need to do is we need to multiply both numbers by the same number. In this case, we multiply both of them by 3. And if you take 45 and divide it by 3, so 45 divided by 3, you still get 15. It's the same thing, it just looks different. All right, if I asked you which number is bigger, 45 over 3 or 15 over 1, a lot of people would say 45 over 3 is bigger, but it's not bigger, it just looks different. It's the same thing. Yeah, okay, I understand fractions can be complicated. But in this case here, now that my bottom numbers match, I can go ahead and multiply this out. So, I'm sorry, subtract it out. So 45 minus 8, so that'd be 37. 37 over 3. Now check to see if we can simplify it by dividing either 37 or 3 by the same number, which we can't, right? If it was 36 over 3, we could divide it. If it was 39 over 3, we could divide it. but it's not, it's 37. So 37 does not divide by 3. So we're basically going to end up with 37 over 3. And that's about as best as we can get that answer. Okay. I got to make sure I finish this. So I'm going to keep things moving. All right, now this one here with number 11, we have the same variable plugins for multiple variables, right? Because we have 2 x's and 2 y's. So when I start plugging things in, I got to make sure that everywhere I see x, I'm going to have to plug in -6. And everywhere I see, okay, now this one's a little bit of a tricky one because I'm going to put some exponent looking things in there. And then x is, again, -6. So again, I'm going to put in a bubble here, a parenthesis. And 8 is y. So I put the parenthesis here so I can make sure I put the negative inside the parenthesis. I'll make sure it's the same one. Now this one here has the negative on the outside, right? The y, if you look at it, has the negative on the outside. So that's not going to be affected. So if I look at them, -6 square, but this one does not have the 8. So the 8 is going to be the only thing that's squared, not the negative. So in other words, this one is going to stay negative. Okay, let's go ahead and work this out. So I have -6 square, so that's going to be 36. Because again, negative times negative is positive. Now the negative is going to stay here because it's not affected by the exponent. So this is going to be -64. Because positive 8 times positive 8 is 64. But we still got to subtract that 64, so it's going to be -64. All right, I don't need that parenthesis anymore. Now in this case here, let's see, I got a negative. Okay, I could either multiply -6 times 8 and I would get -48, but I'd end up with this double negative where I have minus -48. So either way I do this, it's going to end up being the same thing. But you could also just remember every time you see a double negative, so like a negative, parenthesis negative, like we do right here, that's just going to turn it positive. Because if you remember when we were talking about integers, negative can also mean opposite. So like if I have -7, I could also say that it means opposite of 7. So opposite of negative is positive. So opposite of negative is positive. So that's why we would get negative. Now let's see, what is 64 minus 36? So that would be 28. And we still have that plus 48. So 6 times 8 is 48. So that's where the 48 came from. Now in this case here, I'm going to take the absolute value of -28, which would just be 28 plus 48. And I think we're going to be almost done with that one. Just put this a little bit easier to follow. And that would give us 76. There we go. Okay, now for number 12, let's see, this one also has a fraction, so it looks like I'm gonna have to, I can type fractions, it just takes a little bit longer. So 2/5, and then A is now 3 plus 2, and B is now gonna be -4. And I have 2 parentheses, so I'm gonna, again, some people are okay with using 2 parentheses, but just remember you got to watch out for which parentheses group with which ones Okay, so now we have, okay, well, let's start with the inside. So again, this parenthesis here is not a grouping symbol. It means multiplication. So 2 times -4. 2 times -4. And that's going to be -8. So be careful with this because again, some students might say, well, it's going to be positive because this is going to be +8 because this is positive. But again, this is going to switch the sign. So -4 times 2 is -8. All right, 2/5 is still there. 3 minus 8 is -5 squared. So again, we have a multiplication and an exponent. So we got to do the exponent. So this is going to be 2/5. And then here I have -5 times -5, which is going to be 25. Now, when multiplying this, I do have a little bit of a choice. You can, and this is what I mean by I got to make a lesson one of these days on just how to work with fractions, because some people might remember fractions, but I think most people don't. But you can do something called cross cancel. But let's go ahead and just stick with what we know, and that is to multiply top number times top number. So this would be 50 times 2. I'm sorry, 25 times 2 is 50. 5 times 1 is 5, so that'd be 50 divided by 5, which in this case would just be 10. So there we go, we got that one done. Ugh. Again, a lot of steps, but that's pretty much the only thing that you have to worry about. I don't think these are particularly difficult, but it's just kind of a lot of steps on some of these, and you got to make sure you do the proper amount of steps each time. All right, so with these ones here, looks like we got some more stuff going on. So W has been replaced with 2. And in this case here, I don't really need to worry about it because I'm not putting a negative. Like if it told me to put in -2, then I'd have to put in a parenthesis to make sure that everything, goes where it needs to go. But in this case, it's not really that necessary. And I'm going to need to put a parenthesis here around V, because in this case, it will serve as a multiplication symbol. And let's see, 2 times 18. There we go. Woo. Kind of a lot of stuff to put in there. But we plugged everything in, everything has been substituted, so now we can begin evaluating it. So again, evaluate means do everything. So evaluate everything. They start with EV, so just remember that. So let's see, 2 to the 3rd power, so that means 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. So that means this number will be 8 minus, and then 4 times 18. So 18, 36. 36 times 2 is 72. So 72 over, and then 2 times 18, that would be 36. So root 36. All right, 8 minus 72. And that would be -64. So it looks like we're going to have a negative number here. And then 36. So square root of 36. So again, what 2 numbers can I multiply to get 36? Should be easy. 6 times 6 makes 36. So if we work backwards, we should get 6. Now, let's see. We end up with another fraction. So 64 cannot divide by 6. So we're going to have to reduce this fraction as much as we can. So let's see. They're both even numbers. So let's divide them both in half and then check it to see if there's anything else we can divide it by. So divide this by 2 and divide this by 2. And 32 and 3 no longer have any common numbers that they can both be divided by. So that's going to be our final answer is -32 over 2. I'm sorry, 3. All right, with this next one here, this one has a bit of a trick as well, and that is, it looks like we're going to have to use an exponent on a fraction. So m is going to be replaced with 1/4. All right, so 2 times 1/4. So we also have to square the 1/4. So 1/4 times 1/4. So when in doubt, write it out. So if you're not sure what 1/4 square, remember that square means times itself. So this means 1/4 times 1/4. So this would be 1/16. So 2 times 1/16 plus, and then 9 times 1/4. Now again, I'm going to put a 1 under these just so it's a little bit easier to work with. And then multiply them together. So this would be 2/16 plus 9 times 1 is 9. So top numbers times top number and bottom number times bottom numbers. Now I have 2 fractions and I need to add them together. So again, when I'm adding fractions, I need that bottom number to be the same. So when you need bottom numbers to be the same, you can either reduce one number or you can make the other number bigger. So I think in this case, it might be easier to make the other number bigger. So let's stick with 16 as our bottom number, because I can easily change this to make 16. So what I'm going to need to do is times this by, well, okay, I need to times the bottom number by 4, because 4 times 4 is how you get 16. So 16 here, and then 9 times 4 is 36. And again, 36/16 and 9/4 are the same thing. They just look different. And in this case here, I get 38/16. When you add or subtract, the bottom number of a fraction does not change. Now, in this case here, again, we should try to divide it, but if we cannot divide it, then let's reduce it, all right? So again, that's one of our goals, is to put our answer in simplest form possible. So divide them both by 2. So 38 divided by 2 is 19, and 16 divided by 2 is 8. And there are no more common numbers that we can divide our top and bottom number by. So that's going to be it for this one. Now we're almost to the end of our exercise list. So let's go ahead and keep things moving along. All right, so the third and final type of exercise is to simplify each expression below by distributing and or combining like terms. So before we go on, I want to go ahead and quickly define a like term. So a like term has the same variable. Terms with the same variable. Now there's also another part of that, and that is that they also have to have the same power on those variables. Now, we're going to be using a lot of this because Algebra 2, the biggest things that Algebra 2 is known for is functions and polynomials. And with functions and polynomials, you are going to be using a lot of variables and powers. So I'm going to try to get you into the habit of, good habits, so that when you do get to functions and polynomials, you're not going to be lost, all right? So get good habits, so when we get in there, it's just going to be the same thing you've always been doing since the beginning. So a term is a group. So 16x is a group. Now it's not the same as like the parenthesis kind of group, but in this case, it also includes any signs like positive or negative. So in this case here, I have my x group, 16x and negative 7x. They're both x numbers, so that means these two are like terms. Now, even though it says the same variable, it also means if they don't have a variable. So negative 11 and positive 10 are also like groups. So in this case here, let's go ahead and combine these together. Now, anytime you have numbers without variables, those are called constants. Those are always at the last thing that you have on in your group. Okay, so again, as we start going on, we're going to have to put things in function notation, or polynomial standard form means that you start from highest power to lowest power. So make sure we get this right. So highest power to lowest power, but again, we'll get there when we get there. But for now, x goes first. 16 minus 7, that's going to be 9, x. Now, we work on the orange group, which are, again, are the constant values, which means they have no variable. And this is 10 minus 11. So 10 minus 11 is going to be 1. Now, these are not like terms, 9x and -1. So again, they're not like terms, so we cannot put those together. Since we can't put them together, this is the simplest way that we can express our answer. Now again, in the directions it says to use distributive property. So when we are going over distributive property, I'll sometimes get students that say, well, why do we have to learn distributive property? Can't we just add the groups together? Well, if you look at this one here, can we add 3n and -7? No, we can't put them together. That's why we have distributive property, because sometimes we don't have known values that we're working with. So in this case, n could be any type of number. So let's go and put these together. 13 plus 2. Now I'm going to use distributive property, so I'm going to multiply 2 times 3. And that would be 6, and put the n on there, so we still have the n, and this is 2, so now we have to multiply 2 times the other number, so in this case, 2 times -7. So be careful with the signs. So in this case, it's 2 times -7, and positive times negative is going to be negative. And in this case here, 19n just sort of stays the same. We don't really need to change anything with that. So there we go. We took care of our parentheses by using distributive property. Now, 13 is the first number here. But again, let's get used to doing things in polynomial and function notation. So in this case here, I'm going to put the variables. And again, we always put the lone numbers, the constant values, in the back, the ones that don't have any variables. So let's go ahead and put 6n and 19n together. So 6 and 19 is going to be 25n. Now again, you got to pay attention to the sign. So looking at the sign, and if you want to circle them, go ahead, all right? But I'm going to kind of try to draw attention to this, that this is 13 and -14. So that's like 13 minus 14, so that would be -1. So the answer to this one would be 25n minus 1. And there you go. That one is now in simplest form, simplest notation. Okay. Moving on to the next one here. Now with this one here, you got to be really careful, because when you're dealing with groups with parentheses, there is one that always confuses people, and that is, what if you have a negative in front of a group, or a negative in front of a parenthesis? So again, this one always gets kind of lost. So for this first one here, this is kind of easy, because I just have 6 times the group of c minus 2. Or if I read this algebraically, I would say 6 times the difference of c and 2. So again, that's the way you would say it, because we don't say, well, in math terms, we don't say parenthesis. We use words like difference in this case to mean subtract, and that you do that first. And just a quick reminder, it's sum, difference, product, quotient. So when you hear those words, sum, difference, product, quotient, that means it's in parentheses. Anyway, so 6c, so 6 times c is 6c. Now I need to multiply 6 times -2. Okay, that was easy. Nothing tricky there. But again, this is the part you got to worry about. This is the part that is different, because we have a minus on the group. So this means we subtract everything in that group. So that 8C, that's being subtracted. That 1 at the end, that's also being subtracted. So again, this is like saying -1 times these two things. Because it's kind of weird that we see negatives just all on their own, but we can also think of a negative on its own like -1. So in this case here, we have -1 times 8C and -1 times +1. So be careful with that. This is one of these things, again, that I always see people mess up. And they'll usually make the first number negative, but then when it comes to the second number, it doesn't get the negative. So make sure you can make both of those numbers. You reverse the signs of everything in there. All right, so let's go ahead and move on now. 6C minus 8C. So 6 minus 8 is -2, and the C stays the same. Now we be careful because we're not changing powers. If you add or subtract terms, you're not going to be changing the power. All right, so let's see, -12 and -1. So they're both negative. So remember, negative and negative, if you combine them like add or subtract, they will make a bigger negative. It's not the same as multiplying two negatives. If you multiply two negatives, you will end up with a positive, but if you add a negative to another negative number, or take a negative number and subtract a number, then you basically end up with a bigger negative. All right, so with this one here, let's look at this. So we have X's and Y's. This one, oh wait, sorry, no, Y's and Z's. So with this one, we have two variables. So if there are two variables, which one do we take care of first? Well, if you have two sets of variables, you do them in alphabetical order. So in this case, we know Y comes before Z. So let's go ahead and take care of our Y's, which in this case, Y already comes naturally first. So let's just go ahead and put it here. So we have -15. And here's another thing that's kind of tricky is that if you see a variable by itself, it means one of that variable. So in this case here, I have -15 plus 1y, so that would be -14y. Because again, that's plus 1y. Okay, now I have -7z and add 9z. So 9 minus 7 is going to be 2, so that's going to be 2z. And since my 9 is bigger and it's positive, that means the next step will also be positive. All right, so that one was pretty easy, but again, the only thing they wanted to make sure you knew is that if you have multiple variables, you've got to put them in alphabetical order. Okay, this looks like it's the last exercise, so I think we are going to be done after this. Bell is going to ring in like a minute or two, so I'm going to try to get through this as fast as I can, but you know, I do want to finish this. So let's go ahead and distribute the 3. So 3 times 3 is 9. And A is going to stay there because, you know, 3A times 3. Now, again, watch your signs because this is, we're not going to change the sign on this one. It's going to stay the same. So this is 3 times -5, which is -15. Variable stays. Now, again, this is the one that you got to watch out for because this is the one where there's a group. So that means we subtract the A. But we're also subtracting the -7b. If you take away a negative or subtract a negative, you take away its negative, which means it's now positive. Or again, you can also read that as opposite. So opposite of negative is positive. So that's why we end up with 7b plus 7b. And again, A goes before B. So let's go ahead and combine this. So this is 8a because 9a minus 1a is 8a. And here I have -15 and -7, so that would be, oops, B. So 7 minus 15 would be -8, so we get -8B. Whew. Tongue twisting. Okay, and that's it for that one. All right, so again, I'm gonna finish this up and then that'll be it. So we're on the last one. So let's go ahead and take care of this. So negative 8x plus. Now with this one here, be careful because the negative goes with that 8. So the outside number is negative 8. So anything you multiply by 8, that negative has to go with it. So again, this is another tricky one. So please, 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 if you don't know this, really, really learn it because it is one of those things that I always see happen all the time. So if you see a negative on the outside, that negative belongs with the 8. Okay, that's not a regular 8, that is negative 8. So anywhere the 8 goes, that negative is going to go with it. So that's going to change it to negative 8y. Same is true with this one here. I have negative 3. So that means I'm going to have to multiply everything by negative 3. So negative 3 times negative 5, positive 15. Okay, and don't forget the x. Negative 3 times negative 2. Negative times negative is positive. And then from here, we just combine our like terms. So we have negative 16x and 15x. And now that would be negative 1x. But normally we don't include the 1, right? So if we're writing the answer, we don't usually put the 1 in there because, well, we already know that any time we see a variable by itself, it's always going to be considered to be 1, or in this case, negative 1. Now in this case here, I have negative 8y and 6y. Oops. Oops. So that would be negative 2y. So again, going negative 8 and positive 6, that would be negative 2y. And there we go. Now with this one, well, actually with this assignment, I should say, so to clarify something that's going on. So with this assignment, you might be looking at this and saying to yourself, wait a minute, isn't this in the week 1 packet? Okay, so if you forgot what I said the last time on Friday or Thursday or whatever day we had our last lesson last week, sometimes there are going to be repeats of assignments in different packets. Now, I do this sometimes because, one, I don't know what I'm going to be able to cover in the week that we have, and I usually have to make these weekets like, I have to make the packets weeks ahead of time, and it's kind of hard to plan, you know, beyond a week. So I do this kind of to cover myself in case we cover more than we need to or something like that. And I do this for another reason, and that is sometimes students don't get the packets right away. Sometimes it could be a week later they'll get the packet. So rather than having them start on a packet that they haven't got yet, they haven't received in the mail, they can work on the previous week's packet and it's the same assignment. So yeah, this particular assignment and probably another one are in both the week 1 and week 2 packets. So the question I'm usually going to get is, do I have to do both assignments? And the answer is no. You do not have to do assignments. You have to do this assignment either from the week 1 or the week 2 packet. Now there would be an exception, and that is, let's say you did the week 1 packet, and now that we covered it, you're thinking to yourself, I think I got a lot of them wrong. You can redo the packet. You can redo this assignment in packet 2 so that you get the better score. If you do both of them, you will get the better score. But if you feel like you already did this and you got a good score, then you don't need to do it in week 2. So this will count as the same assignment. All right, so this has been assigned today, so this will be the attendance for today. So again, you don't need to do both of them. If you did them last week, you don't need to do it today and you will still get the attendance. So again, that's something that you got to watch out for. And this is probably going to happen a few more times just because it's really hard to plan so far in advance. And it's always kind of hard to tell what's going on, especially when we have a day like this where we have Martin Luther King Day. So I think the next lesson will be on Thursday. So I will see you then. So if there are no other questions, I'm going to go ahead and end the lesson because the bell already rang. So hopefully you'll be on your way to your next class. So bye-bye for today. See you Thursday.